Agents become truly risky when their reasoning can reach real systems. Tools are the crossing point, what the agent can read, change, trigger, or expose. In this section, we'll treat tool access as a core security boundary. Module 1 gave us the foundation: why agents are different, how autonomous workflows get attacked, and how insecure defaults turn into exploitable behavior. Now we move from recognizing risk to controlling it, starting with the boundary that matters most: tool access. On its own, a language model mainly produces text. The security picture changes when we give it tools. Its output can become an API call, a database query, an email, a file write, a refund, or even a deployment. That makes tool access a boundary of real power. If the agent is tricked, compromised, or simply wrong, it can misuse any capability it is allowed to invoke. So we secure agents by asking, what can each tool do, what data can it expose, and what side effects can it create? The key shift happens when generated text becomes an action. A model response may be incorrect or manipulated, but it is often still just information. Risk escalates when the agent selects a tool, builds arguments, and sends them to a privileged system. At that point, a bad instruction can delete data, move money, or message customers. Security cannot stop at checking the prompt. We need checkpoints before execution. Should this tool be used at all? And are these exact arguments authorized, valid, and safe? One useful starting point is to separate tools into two risk classes. Read tools look things up: indexes, logs, documentation, customer records. They usually carry lower operational risk because they do not change the system, but they can still leak sensitive data, so access still matters. Write tools are different. They send emails, change records, issue refunds, write files, deploy code, or open tickets. Because they create side effects, they need stronger guardrails, tight permissions, input validation, audit logs, and sometimes human approval before the action runs. A common mistake is to rank tools by one label. Read-only means safe, write access means dangerous. Real risk is more situational. A read-only code search tool can be high risk if it reveals secrets, exploitable flaws, or proprietary logic. A write tool may be lower risk if it only changes disposable sandbox data. Evaluate 4 dimensions together: what the tool can do, how sensitive the data is, where it runs, and whether mistakes can be undone. Risk rises sharply in production, customer, credential, and money-moving contexts, where small actions can create large consequences. Some capabilities deserve especially careful treatment. The highest risk tools are the ones that can unlock other systems, move money, expose regulated data, or change the operating environment itself. A tool that reads secrets can become a launch point for wider compromise. A billing or refund tool can create immediate financial loss. Access to customer, employee, or support data brings privacy and compliance obligations. And anything that changes admin settings, code, infrastructure, or internal APIs can reshape security for everyone. Treat these capabilities as privileged by default, with stronger approval, monitoring, and containment. The same pattern appears in many incidents. A fake support ticket can trick an agent into exporting customer records. A compromised workflow can use email to leak confidential files. A refund tool can be called repeatedly with altered arguments. Even deployment tools can cause outages when an agent misunderstands a task. Powerful tools amplify both mistakes and attacks, so controls need to validate actions before impact occurs. Tool invocation controls act as the agent's permission layer. Before any tool runs, the system checks whether the tool is approved, whether the user and role fit the request, whether the intent is legitimate, and whether the arguments are safe. The outcome is not always yes or no. Low-risk actions may run automatically. Sensitive actions may require human review. Suspicious actions should be blocked and logged. By applying controls before execution, powerful tool access becomes governed behavior, rate-limited, auditable, isolated, and aligned with policy. Tool access should be managed as a security boundary, not a convenience setting. An allow list says, these are the only tools this agent may use, which fits production workflows because anything unexpected is blocked by default. A deny list does the opposite. It blocks known dangerous tools, but may miss new, renamed, or newly connected capabilities. The stronger pattern is default deny plus explicit allow. Permissions can then change based on role, task, tenant, environment, and workflow stage, especially near sensitive data or production systems. Approval to use a tool is only the first gate. The second gate is the arguments. A harmless tool can become dangerous if the agent passes the wrong recipient, file path, account, amount, or query. Validation makes the call enforceable. Check required fields, types, formats, ranges, and allowed values. Then bind sensitive fields to verified context, such as the signed-in user, tenant, ticket, or account. If inputs are ambiguous, excessive, external, or inconsistent with the request, block the call or escalate it for review before anything executes. Even well-designed agents can fail under pressure. A bad configuration, a compromised account, or a malicious prompt can turn normal tool access into high-impact damage. Limits reduce that blast radius. Rate limits control frequency, such as requests per minute. Quotas control total impact, such as refunds per day, records exported, or emails sent. Burst controls catch sudden spikes, retry loops, and exfiltration patterns before they scale. The rule of thumb is simple. The more sensitive the tool, and the closer it is to production, the tighter the limits should be. Strong tool control asks more than, is this tool permitted? It asks, is this tool appropriate right now for this user in this situation? The decision can factor in role, authentication strength, tenant, geography, device trust, and session risk. It also considers intent. A support agent may need one customer ticket, but not every record in the database. Environment matters too. Writing to production should require more assurance than working in a sandbox. With context, systems can allow, block, or escalate without granting broad, permanent access. For high-risk actions, the agent should not be the final authority. When an action could move money, change security settings, create legal exposure, or affect customers, policy should pause the workflow and require a real human decision. The request needs enough context to judge it. What will happen? Why the agent recommends it? What evidence supports it? The risk score, and the expected impact. The approver must be authorized and independent. Then the system either executes or blocks the action, and records the decision for audits, incident review, and governance. The core lesson is simple. Tools are where agent reasoning becomes action. So tool access is a security boundary. Classify read and write tools, identify sensitive capabilities, default deny access, validate arguments, limit rates, require approvals, and log decisions. Together, these controls reduce blast radius and make agent behavior governable. Next, we'll turn this into least privilege agent design, then stronger schemas and isolation.